Okay, so on this question, a rocket is being launched. After a while, it rises at a constant velocity of 25 miles per second. That's fast, 25 miles every second. An observer is standing 77 miles from the launch site. There's the 77. How fast is the distance between the rocket and the observer changing when the rocket is at a height of 36 miles? Okay, well, so I got a nice little picture for us there. So step number one is always to find your rate letters. So find your rate letters. Okay, so that means read back over the words, find anytime they talk about a rate, how fast something's happening. Rocket is being launched. After a while, it rises at a constant velocity. That's a rate, 25 miles per second. Okay, there's a rate. I got to write that somehow. What is that? Well, call this y here. In fact, let me do a better job on that. Call this y. And that's telling us that dy dt is positive 25. Now I know you might say, well, Mr. It's already 36. Well, I know that you got to kind of keep track of the fact that it's a video, it's in motion, and then we freeze the frame. So the rocket's going up, the sound effect up. It's going up, right? We have a video, it's going up, 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 and boom, we freeze the frame right there. So right then, it's 36 miles high. But you can still call it a variable because it's varying. The height is varying, it's going up, right? And so you can call it 36, you can call it y, they're both true. And they're telling me dy dt is plus 25. Now, why plus, not minus? Because it's increasing. Anytime a distance is growing, then that's positive change. Anytime it's shrinking, that's negative change, right? Y is getting bigger, isn't it? Y is the distance from the ground up to the rocket. Well, if the rocket's going up, that distance is growing. It's increasing by 25 miles every second. Every second, that 1 second later, rocket's going to be at 37 miles high. 1 second later, 38 miles. 1 second later, 39 miles. Right? That y, that distance altitude of the rocket is going up. Oh no, I'm sorry. It's going 1 second later, it's going to go up 25 miles. Yeah. So whatever, 25 added to, what is that? 61. So 1 second later, it's at 61 miles high. And then add 25 again. 1 second later, it's whatever that'd be, 86 miles high, etc. Every second, that rocket goes up 25 more miles. That Y is increasing, it's growing by 25 miles every second. So there's the first rate variable that they speak of. What else do they speak of? Because there's 25. Okay. An observer is standing 77 miles. No, that's just a distance. That's not a rate. How fast is the distance between the rocket and the observer changing? Where's that? Well, that's right here. I usually call that z for distance. You don't have to. Here, let me put a little arrow there. So from the observer to the rocket, I'm going to call that z. You could call it x. So let's just call it x. How about that? Let's call it x. It's the distance from the observer to the rocket. And they're asking me, how fast is that thing changing? Whoops, I didn't finish right here. dy dt is, come on, I thought I changed that, is plus 25. And then dx dt is what they're asking me for, right? How fast is that changing? That distance, how fast is it changing, right? How fast is the distance between the rocket and the observer changing when the rocket's at a height of 36 miles? All right. So these are the only rates they speak of. It's important to identify. Next, write some equation relating only those letters. So only the rate letters. In this case, that's X and Y and X, whatever, the order doesn't matter, right? These are the only rate letters, nothing else. I'm not going to put in an angle theta. I'm not going to call this Z or anything else. Just how did I know? Well, because I just read the words and they spoke of dy dt and they spoke of dx dt. Put y and I put x on the diagram. So now I need an equation relating just x, y. Well, it's pretty clear. 77 squared plus y squared is x squared, right? There's my equation. So 77 squared plus, what is it? Y squared is x squared. All right, see how I came up with that? So I'm looking right here. I went 70, it's right triangle, right? A squared plus b squared is c squared. 77 squared. Now you might wonder, why didn't you do 36 here? Well, because I need y, right? I need y and I need x. And then this is x. So I knew I needed y and x. So I'm going to use y, not the 36 right now. I'll put 36 in at the end. But for now, I need 77, y, and x. Because I need y and x. And the 77, by the way, is not changing, right? This person is standing 77 feet, 77 miles from the ground, from the point where the rocket launched on the ground. That's not changing. He's just standing there. All right. And then step 3. And once you got that, you DDT both sides. So let's do that. So we come in here and go, okay. Come in here and go. DDT this side and DDT that side. This part's just 0. Right? Any constant number, it's constant. It doesn't have a variable, it doesn't have a letter. Its rate of change is 0. It's not changing at all. This is 2, we're bringing down the 2. 2y, the y is subtract 1 from the power because first power, but times dy dt because of the chain rule equals, and same thing here, bring down the 2. Even x, lower the power by 1, is going to be dx dt because we're taking the derivative of x with respect to time. Remember, it's ddt of both sides. And t is not the same as x. So that means you got to do the chain rule. All right. So there it is. Now let's just get rid of that guy. Whoops. Let's get rid of that guy. Who cares? Divide by 2, divide by 2. Boom, boom. So we have y dy dt is x dx dt. Nice. All right. Step 4. Plug in the numbers. Plug in the numbers. What numbers? Well, whatever we got, everything we need. So let's go look at it. So what do we got? Well, we got dy dt, that's 25. We get that one. So that's positive 20, 25 there. Okay. Do we have y or x? Y is 36. We can do that now. Okay. Do we know x? Now we can get x using the triangle, right? 77 squared plus 36 squared is x squared. Now I'll use the number. See how I change what I'm using at the moment? Now I'm free to use all, right? I'm on step 4, plugging in all the numbers. Oops, that's kind of scribbly. What did I do there? Plugging in all the numbers, right? I'm on step 4 and I'm plugging in all the numbers. So up here, I'm going to go 77 squared plus 36 squared is x squared. So then root it. So then x equals that. Square root of 77 squared plus 36 squared. Do that. 7 squared plus 36 squared. There's x. And dx dt is what we're looking for. Get that right. X is squared 77 squared plus 36 squared. Yep. Okay. And last step, let's solve this thing. Let's divide both sides by that weird looking square root of 77 squared plus 36 squared plus 36 squared. Boom, boom. And so dx dt. Let's go to Desmos. 36 times 25 over the root. 36 times 25 over the root. Over the square root. 36 times 25 over the root of 77 plus 36, both squared. 77, 36, both squared. 36, both squared. There it is. 10.588. 10.588. So we're getting 10.588. Is that what they got? They did. Miles per second. So that's how fast the distance between the observer and the rocket is changing. It's growing by 10.588, 10.5 miles every second as that rocket shoots up into the sky. And so there we go.